Dodie, let me start today's episode with a quote, and you tell me if you know who said it.
Okay, I didn't know you could do voices, Connor, but let's hear it.
We shall escape the absurdity of growing a whole chicken in order to eat the breast or the wing by growing those parts separately under a sustainable medium. Okay, there's the voice.
Oh, is this a person who smokes a cigar by any chance?
It is absolutely. It's no other than Winnie himself, Mr. Fight Them on the Beaches, Winston Churchill.
I could have guessed.
So he said that way back in 1931 and was imagining a world where clean meat grown in vats had become a reality and a sustainable way forward for protein.
Okay, clean meat?
Exactly. So on today's episode, I want to look closer at some of the alternatives to meat that are out there and what might be waiting for us in the future. And spoiler alert, guess what? This episode includes fungi.
Because you cannot help yourself.
I refuse to quit, and that's what matters on today's episode of Discovery Matters.
Okay, Connor, who are you bringing to this episode?
Well, let's start with mycology, shall we? Let's start with Tim.
Hi, I'm Tim Finnigan. I'm currently the Chief Scientific Advisor for Quorn Foods.
I know Quorn, that's the meat substitute product.
Exactly. The origins of Quorn, believe it or not, start all the way back in the 1960s.
It was one man's big idea, one man's vision, and that was Lord Rank. He was looking at what was happening. This is pre-Green Revolution, and at a time when the world genuinely thought that it was going to run out of food. And he just decided to do this amazing thing and set his team out to go and find a new source of protein. He decided that something needed to be done.
So, Lord Joseph Arthur Rank's team went looking for a microorganism and one that would transform the plentiful starch that was around into the less than plentiful protein.
I think that was quite a brave thing to do at the time, because although mankind has eaten microorganisms for thousands of years, it's usually because they do something to something, like yeast in the manufacture of bread. Whereas this idea was, why not actually look at the whole of the biomass itself?
So they looked at over 3,000 soil samples worldwide.
So we're looking at eating dirt.
Well, it's not really, right? It's things that live in dirt, okay? So eventually, one day in 1967, they found what they were looking for, and where they found it blows my mind.
And again, so the story goes, it was in somebody's compost heap in Marlow Bottom in Buckinghamshire.
So there, in a compost heap, in a little village, like 8 miles from where we are at the headquarters in the UK of Cytiva, they came across this tiny member of the fungi family, Fusarium venenatum. And by the 1980s, Lord Rank was given permission to sell this microprotein for human consumption, and voila, Quorn was born.
We know it's got amazing nutrition. We know that it's environmentally very benign relative to other sources of protein. And most importantly of all, it actually creates fantastic food that is sold, available currently in 17 countries worldwide. An amazing journey for one man's idea and a tiny little member of the fungi family in a compost heap.
All right, describe how that fermentation process works exactly.
So Tim says you can kind of think of it like a very large brewery. And
we've spoken about breweries and yeast.
Yeah, we love that. Yeah.
The difference being that, we're harvesting the solids and not the liquid. But the start of it is something that's quite amazing, because, if you've ever made bread or wine at home, you open your yeast sachet. That's kind of exactly what starts, what happens at the start of each fermentation run to produce mycoprotein. And those few tiny little spores of our production strain get brought back to life in a little bit of sugar solution and just sit there happily in about 5 litres. until they get to a certain sort of growth concentration, and then they get put into the fermenter, which is about 160 meter cubed, 160,000 liters. So what a dilution that is, 5 liters to. And there it sort of enters this what's called the batch phase, where it grows quite happily for about 4 or 5 days, and quite rapidly actually up to a kind of a working concentration. And I think here's where the engineering magic happens, because not only is that done under very sterile conditions, because you don't want anything else in there but our little mycoprotein, but we're then able to hold it at that point of maximum growth and harvest at the same rate that it grows. And we can do that for something like 35 days until we stop, clean down, and start all over again.
That's incredible.
So, there's no limit to what these remarkable organisms can do.
You're right. So when it comes to corn, what is it really that makes it such a flexible protein foodstuff?
Yeah, so the big reason is that it's actually filamentous, which means it's,
That's a big word. It means...
So when a cell continues to elongate, it doesn't divide. It just kind of stretches, right? So you get textures.
Oh, like gluten.
Mm-hmm.
Our fermenters are what's called airlift, which means there are no moving parts. So they are just like a big recirculating mass of growing mycoprotein with air going in at the bottom through, which causes bubbles. The bubbles rise up to a certain height. Then the gases, pressure changes. The gases disengage and the fluid drops down. But there's quite a high recirculation velocity. That actually works very well with filamentous fungi in what's called submerged culture. Because otherwise, if you try to do it in a stirred tank, then it's quite difficult because you've got these kind of long fibers. Lots of other fungi prefer to grow as little sort of tight balls. So maintaining this filamentous nature is actually really, really important for the subsequent food that's produced. And the reason for that is that there's kind of an optimal dimension to these mycelia, and that there's kind of roughly 3 to 5 microns across, which is sort of human hair territory, I guess, and probably about 750 microns long with kind of branches on them.
And in that sense, it's almost as if nature's done the heavy lifting for Tim and the team at Quorn.
How kind.
So unlike other plant proteins where you're looking to extract protein and isolate it and extrude it and produce texture that way, all that has to happen with mycoprotein is you cook it with a little bit of binder in there, freeze it, and that's it. And it's the act of freezing that pushes those filamentous fibers together and creates then a fibrous bundle that emulates meat, and particularly chicken texture. The mycoprotein, when it's harvested, is a bit like bread dough without the elasticity. So you just look at it and think, how on earth can you create something that tastes like chicken from that? And it's just simply cooking and freezing.
Oh, I love that this is neither vegetable nor animal.
I know, it's like that 20 questions game, animal, vegetable, or mineral, and no one's ever going to get it because there's none of those.
Okay, so we've covered mycoprotein, even though, Connor, you'll never be done talking about it. But what other new alternative protein sources are out there right now?
So, welcome to the world of cell-cultured seafood. And your guide today is Dr. Lauran Madden.
I've always been, very interested in, applying a lot of the engineering problem-solving principles to biological systems. And, how can we take advantage of this, naturally occurring phenomena and very interesting processes and networks that happen in cells and really create solutions and technologies to, help us move forward.
Lauran is the Chief Technology Officer at BlueNalu in California, and they work with cell-cultured seafood.
So I was actually the first employee at BlueNalu. So when I joined, even just the concept of joining, I looked at the initial job description, and when you look at the top line, creating seafood from cells, you think, oh, that's interesting. But then when you looked at all the technologies that are needed, creating robust cell cultures, creating the expansion technologies, the tissue engineering technologies to reform them into a product, all of those, I was like, I've done that before, not for this product necessarily, and with different applications, but the fundamental building blocks, existed in a lot of regenerative medicine and a lot of chemical engineering technologies. The key was, how do you take an existing industry or multiple different types of technologies and optimize them for this specific application in food?
So cell cultured seafood sounds, okay. Is it cool? I don't know. But if that's on my menu card, am I going to order it? I don't know. Tell me more about how it works.
We actually derive all of our fish cell cultures in-house. So we've developed a series of proprietary methods, so can't go into too much detail on, exactly how to isolate the cells of interest from the different tissues. So for example, from muscle, we'll extract the precursor cells and then culture those. The idea is really to generate really stable, robust cell lines that can be, grown out and expanded, and then, typical to a manufacturing process, frozen down into cell banks. So we do not have to go back to the fish. So the idea is not to have to go back, but it's really to create this robust cell line that's a starting point for the manufacturing process.
And Lauran says that what she really focuses on as she tries to create the end product for her work is that she's using both core biology and engineering fundamentals to achieve it.
So I think for me, it was still a really fun scientific problem and engineering problem. And I think one of the awesome things too is that you start actually putting together technical fields that have not worked together before. And so it actually creates a very innovative environment in terms of the problem solving and getting that exchange of ideas.
So the whole thing is really highly multidisciplinary. From different parts of science comes this innovation.
Okay, so you've got engineering, biology, clearly food science. What are the other disciplines that Lauran is bringing together?
There aren't even existing whole genomes for some of the species that we're working on. So we actually have to start creating those foundational tools and then applying them to the new systems, working with the bioprocess engineers, creating new cell culture medias that are animal-free cell culture medias that actually have the right nutrition and combinations to support the correct metabolism. And then, of course, adapting some of the existing technologies to the unique environmental needs of fish cells.
Now, unlike mammalian cells, which, we're really familiar with because, as an industry in biotech, we use them all the time, fish cells are typically at different temperatures, they require different environmental conditions and have special needs.
So the process control is definitely different, and the sensitivities are different from what is out there currently. And I think one of the, on the downstream side, with the food product, I think that's where you get some of the most interesting dynamics, because at the end of the day, the cells coming out of the bioreactor are the building blocks of the product. And we think about them not only, are they correctly expressing the right, genes and proteins, but do they have the correct nutrition? Are they making the right metabolites? So you have those umami flavors, that right saltiness, or that right aspect that uniquely creates seafood, versus having a chicken cell or a beef cell, which is going to have a different flavor composition.
So Lauran explained that one of the main things about seafood that makes it different from, land-based meat, if you like, is the challenge in the supply chain comes from multiple dimensions.
Oh, here we go again with supply chain.
Supply chain.
So there's not only, for example, if you take bluefin tuna or some of the other endangered species, there's a very limited supply, but there's increasing demand. So how do you, with a growing population and growing demand for certain products, provide that sensory experience and that product experience without continuing to, need the animal or slaughter the animal and kind of, put pressure on those fish stocks. So that's, one solution. And then, one of the other main challenges with seafood is that while it has many health benefits from a nutritional aspect, so lean proteins, omega-3s, all the reasons that doctors will recommend seafood, but due to, environmental contamination in the ocean, it's actually at risk. Bluefin specifically has very high mercury content. Not everybody can eat the product. Now, there's a lot more news out there about microplastics or PCBs or other things that are, naturally in the ocean that are getting into the food supply that really call into question, is this actually healthier if along with that nutritious profile, you're kind of getting these ride-along environmental contaminants?
And this is becoming more and more important as people understand more and more about the impact of industrial fishing, not just on fish stocks, but actually what's in those fish as well. For Lauran and BlueNalu, the idea is to make sure that their products are competitive with the conventional counterparts.
And really, we want to make it as easy as possible for consumers to adopt them. If you want to create a solution, we need to please the consumers first and make sure not only from a sensory perspective, taste and texture, but also that it's not going to be overly impactful on the wallet, so to speak.
So now it's like, Connor, you and I are a little bit obsessed with food besides mushrooms. Maybe we're always hungry. We talked recently about chocolate. And I guess what this all adds up to is that there are better alternatives for almost everything that we consume every day.
Do we really? I mean, the only thing we can do is keep asking that question and meeting more and more really interesting scientists like Lauran and Tim, who keep pushing the boundaries of what's possible with food.
Well, let's do that. So keep tuning in. Thank you for listening. Our executive producer is Andrea Killen. Discovery Matters is produced with the help of Bethany Grace Armitt Brewster, who has been promoted from intern to full-time associate with us at Cytiva. So congratulations and a big formal welcome to Bethany.
Yay, go Bethany. Congratulations. Welcome to the team.
Editing, mixing, and music is by Tom Henley and Banda Productions. My name is Dodie Axelson.
And I'm Connor McKechnie. Make sure you rate us on Spotify or whatever platform you use. We'll see you when we come back with another episode of Discovery Matters.
Bye for now.